Hey, mathematicians, 13.3, geometric probability. This is going to pull you back to 7th grade math where you talked about probability, favorable divided by total. Only this time we're going to be using geometric figures. So let's get started right away. All right, geometric probability is the probability that involves measures such as length and area. All right, length probability ratio. It's what is the odds that something's going to happen in the given segment or the favorable segment compared to the entire segment. All right, that's what it's going to be. So let's take a look. Point R is chosen at random on this line. What's the probability that it falls in MN? All right, so favorable is right here. That's 13. All right, the total options that there are is right here. So 8 plus 13 is 21, plus 9 is 30. So the probability that point R is chosen and it's in MN is 13 out of 30. All right, you're in the underground station waiting for the next subway car, and you're unsure how long ago the last one left. You do know that the subway comes every 16 minutes. What is the probability that you will get picked up in the next 12 minutes? Okay, so we know it comes every 16 minutes. Okay, that's the total. What's the probability you're going to get picked up in the next 12? All right, so favorable is 12 out of 16 total is going to be 3/4. 3/4. Now, one could argue if you haven't seen it, it probably could have been like 15 minutes ago it left, so on. We're just going to go, there's a total of 16 minutes. You're here for 12 out of 16. All right, area probability. It's area of the favorable amount divided by the total area. That's what we're talking about. All right, what's the area of this part that you want it in? What's the area of the whole thing? So if targets of the dartboard are formed by 3 concentric circles, that means 3 circles in the inside. If the diameter of the central circle is 4 inches and circles are spread 3 inches apart. Oops. There we go. There we go. And what is the probability they'll throw a dart in the center of them? So there's 3 concentric circles. So I can make one more circle here. Okay. I'm going to shrink that down a little bit. There we go. And I got 3 here. So the probability that it lands in this center part, well, that area is pi times 2 squared. The area of the entire circle is pi times 10 squared. And so we're going to divide those out. We're going to get 4 out of 100, which is going to be 1 out of 25. All right. So the diameter is 4. That means the area is 2. And then the circles are 3 inches apart. That's what this represents. So 1/25th chance of getting it in the circle, middle circle. If at a carnival you toss a ring and it lands in the red circle shown below, then you win a prize. The diameter of the circle is 4 feet. If the dimensions of the table are 5 by 8, what's the probability that you win the prize? All right. Well, area of the circle is pi times 2 squared. The area of the rectangle is 8 times 5. So it's going to be 4 pi over 32. And I said that wrong. This is a 5 here, which would make it 40. So it's going to be pi over 10. So let's take pi, let's just leave it as divided by 10. Oops, let's turn this on. Pi divided by 10 is going to give us 30, well, I should have known that, 31% chance of landing. 31% chance. All right, here we go. Use the spinner to find P, the probability of the pointer landing on section 3. So this P means the probability of what? Of the pointer landing on section 3. Section 3 is 122 degrees out of 360 total. And then we'll simplify that out. So we've got 61 out of 180. That's your probability. And you can leave your probability as a fraction, a percent, or a decimal. Any of those work. Section 1 is 26. So 26 out of 360 degrees. So we have 13 out of 180. And then when it says 4 or 5, we're going to combine those together. 153 out of 360. And I believe that's simplified. And that is geometric probability. Now, you might see shapes that are a little bit more intensive with finding the area of them, but you've got this. Have a great day. Bye-bye.